Well, hello everyone. On the bench today we have an old knight. This is the KG-670 RC tester, and what RC stands for is resistor capacitor, and it is used to test capacitors, as you may know. Now, I picked this unit up from a place called Create Salvage sometime back, and in fact I picked up quite a bit of equipment from there that I got at reasonable prices, and the thought process was to repair them and put them on the eBay store and sell them. But you know what, I really don't want to go through all that hassle of doing that. So I think what we're going to do is take this unit apart, clean it up, update the capacitors and resistors, get the thing working like it's supposed to, and we're going to give it away. I have many capacitor testers, so I don't need this, and I'm pretty sure there's someone out there that could use a capacitor tester on their bench. Now, this tester here is a little bit different than most on the way it functions. One thing I do like about this one, on the resistor leakage test, when you turn the knob to test, it's spring loaded, so it goes back to where it's in the discharge mode. So if you got this thing on 450 volts over here, there's 450 volts across these two terminals. When you engage this, when you let go of it, it immediately discharges the capacitor, and that helps, you know, prevent getting a shock hazard like the IT28s and the other testers that I have. It's just got a lever switch you flip, and if you forget it and accidentally touch those, you're going to get a nasty shock. But this one is spring loaded. So we're going to take this thing apart, look at it, look at the schematic, see what we need to do to get it up and running. So to get in this thing, we got 6 Phillips screws on the front, and there's 2 standard screws on the back. I've looked at the power cord. The power cord looks in good condition. I'm not going to change it to a 3-wire. I'm completely happy using 2-wire circuits if you know what you're doing. You know, I will mark the positive lead or the hot lead on the line plug, so whoever plugs it in can plug it in the correct way. The handle on the top of this thing is spring loaded, and I like that because a lot of times I'll take handles off of equipment. Like if I want to set a vacuum tube voltmeter on top of this, that handle's out of the way, it's flush with the top of it, so you can set it on the top. But if you need the handle, it's there. So let's go ahead and get this thing tore apart, and we'll have a look inside. So I got all the screws out, and you know, looking at it, there's a few little scars on it, but I think for the most part the case will clean up very nicely. The front panel looks real good. There's a little scratching over here and around where the screws was, but it doesn't look bad at all. All the knobs look good, so they should clean up nicely. Now to get this thing out, all we need to do is just give it a little tug, and we can go ahead and pull it completely out. So as you can see from the top view, we have a 6E5 Magic Eye tube, and I think this is a 6X4 rectifier tube. Got a little transformer. This is our variable resistor for the tuning range, and here's our voltage selector switch. Has quite a few resistors on here we'll need to check. Some precision resistors under the bottom, and there's one cap here on the top. And looking at the bottom side, it looks like there's some things missing. In fact, it looks like it's missing capacitors. There's no, there's only one wire going to this power factor switch off at the power wires. This is our leakage test switch. And this wire here just comes off to a terminal that's broken, sitting there all by itself. So we're going to have to get the schematic out and have a look and see what's going on, because only seeing 3 capacitors in this thing. Should be way more than that. So it looks like somebody started on repairing this at one time and removed the parts and never got back to it. So we're going to go ahead and pull the front panel and the knobs and stuff off so we can go ahead and get this thing cleaned up and get it looking decent. Then we'll see if we can't put it back together. And there we go. 5 minutes later, the unit is basically stripped completely down. So I'm going to go ahead and clean up all the knobs, the front panel, and polish it. Clean up all the controls, the switches, you know, make sure everything's good and electrically sound, so we can get this thing put back together. Got everything cleaned up. I went ahead and polished the top of the chassis a little bit just to get some of that oxidation off of it. Makes it look a little bit better inside. And then we just got to get everything put back together. Then we can see if this thing is going to work. I am hoping there's no major issues, but when you see something that somebody has taken apart to the point where they didn't put it back together, it does make you wonder if you know, something is wrong, if there's a particular reason why it was never put back together. So I guess we'll find that out. So still a lot happening at work right now. I still do not have a manager or a supervisor. I did put in for the job, but at the moment nothing is being done, and that's why it's been so hard to get the time to get out here in the shop and do anything. So hopefully, what I was telling after last week was shut down, which I worked every day, I happen to be off this week because I got to use up some vacation. So we'll gonna get out here in the shop and play around every day. Try to get caught up on some projects that we're working on. You know, the bad thing is every time I get out here I'm working on somebody's equipment instead of doing what I want to do. This was never meant to be a full-time job. It's mostly just to get out here and do what I want to do and share some of the experience with you guys. But you know, things don't always go that way. But But that's life. It's just the way things go sometimes. But I think we're supposed to hear something pretty soon with what's supposed to be going on at work. And we'll see exactly how that goes. It would be nice to just retire and come out here in the shop and work every day, but that's not going to happen right now. Alrighty, moving along. Okay, we have everything back on the face of it. I do not have the tubes installed yet. We want to go through, test everything, get these old caps out, find out what else is missing on here, and then bring it up with the variac supply. Now I do have my variac supply repaired. As you saw in the video of the Johnson Navigator, it quit on me and it had a open winding on the auto transformer, and it was on the outside of it, so it was easily to just clean off the leads and solder a piece of wire and epoxy it back up and got that thing back up and running with no problem. Didn't really matter. I had several of these things sitting around, but this one is a bench top supply that I built a way back, you know, so it's nice to have it back up and going. But I had several more to fall back on, so there won't no problem in that. So I guess we need to get underneath this thing and just find out what all was missing, and go ahead and start replacing some stuff and installing what needs to be installed. So I always found the best way to go through something like this is download the manual, and luckily this manual is clear enough to look at and see what's going on. But if we look at this, this is like the final build underneath the tester, and it's showing installing these 3 capacitors here. And if you look at the bottom of the circuit, you can definitely see that those 3 capacitors are the one that's missing. So we got a 10 microfarad at 500 volt coming off of pin 7 of this tube that should be going to ground. There's another 10 microfarad at 500 volt coming off of terminal 1 of this strip and going to ground. And then up here there should be a 2 microfarad 200 volt coming from the center lug of this control down to this purple wire. And we can clearly see the other 2 capacitors here that are installed or still there. So I need to dig through my capacitor case and see if we can find these 3 missing capacitors, and then we'll go ahead and replace these other 2. Okay, this is one of the moments when you go, I just wonder, you know, from this terminal to this terminal here on the control, there should be a 2 microfarad capacitor at 200 volts. But when you get down here and look, this wire is just wrapped around the terminal, and there has never been solder on this connection. So, has this thing ever worked before? That really makes me wonder. It's like someone started the kit and then didn't ever finish it. Maybe that's why this thing looks to be as in good a shape. You know, there's no wire on the front when fingers touching the front panel or whatever. So yeah, that makes me wonder. Alright, we got to install a 10 microfarad cap, and that is going to go from this solder lug, the ground, over here to this first terminal on this terminal tie strip. And as you can see, positive goes to ground, so that's some type of negative bias supply here. Always make sure you look at that real good before you start installing caps. Now if we look at the unit, we can see this is the ground lug here, and there's already a 0.25 microfarad there in that runner, so we need to get that other cap out of the way too. And I find it best to clip off the top lead where it's attached to the terminal. Then we should be able to heat that up and pull it right out the bottom, just like that. I don't always take what the picture says by word, you know, just look at the schematic. That was capacitor C3, and you can see the positive here is tied to ground, so we just want to verify that that is correct. Okay, we get our first electrolytic installed. Went ahead and pre-bent the leads. And we're going to solder this end, but we're going to leave this other end unsoldered because we got to put a new cap on that side. And we'll go ahead and get our second electrolytic put in. As you can see here down on the ground, we'll go from terminal 2 to pin 7 of the 6x4 rectifier tube, and positive goes to pin 7, and I've already verified that on the schematic. Okay, I'm getting ready to put in our second 10 microfarad cap, and what I like to do is look at the location I'm going to put it, and I don't always use a spaghetti wrap, and when I do, I usually get it from Just Radio. Well, I'm completely out of it at the moment. But what I use is just a piece of wire that has a good insulation on it. And I'll just take this piece of wire and slide it right over my, or this insulation, slide it right over my lead. If you notice in here, they have not done that at all on anything, but on the ones I put in, I always put a sleeve on them, and you know, it kind of helps protect. If somebody reaches in, there's less places for you to touch and get shocked by. Okay, so all our missing caps has been installed. Now I'm going to go ahead and replace the other 3 caps in here, and I'm not going to bore you on replacing caps. Yeah. Okay, kind of a blooper, but a word of warning. I noticed, and I'm laughing, and I'm laughing because I didn't get hurt, and it just kind of really surprised me at what happened here. But on this terminal there was a blob of solder on the back side of it right here, and there's nothing attached to that. So I said, well, you know, I could grab the soldering iron and remove it, but I just grabbed the side cutters and I reached in and I just give it a little quick cut off, and then I was going to hit it with the soldering iron. Well, you notice down here on the bench there's glass, and if we look up here at my Magnum light, now I have to rely on these things because, you know, my eyes are not the best. That piece of solder, when it came off, it came up and hit this glass and shattered it, and there was like a ball of plasma fire. And the first thing I thought, my God, did I have this unit plugged in when I did that? Did I short something out? You know, it just happened so quick. So yeah, be careful. Mistakes like this can happen to anybody, and that was sure woke me up this morning. Alright, the light tube is replaced. All the glass has been cleaned up. And another thing to remember when you're working on stuff is, you know, I've probably done that 100 times. Cut off a piece of solder like that, or a piece of wire, or whatever. But yeah, sometimes you got to be careful. Okay guys, when we was installing these electrolytic capacitors, I was talking about the polarity, making sure that this cap went to ground. And as I'm sitting here checking over my work, what do I notice? I put this 10 microfarad cap in backwards. You see here the ground arrows is going to the tube, and the positive is going to negative. So that's mistake number 2. It happens. You have to be careful, and that's why it's always good to go back and check everything against the schematic after you rebuild stuff. So yes, I'll make mistakes too. Luckily I didn't power this up and blow the cap or tube or something out. So yeah, always double check your work. Okay, so here we go. Everything's all together. I'm gonna go ahead and turn the switch on, and we'll bring it up on the variac. It's about 40 volts. High voltage starting to come up now. It's about 60 volts. About 80 volts now, 172 volts. It's 100 volts. And there's 120 volts, and we're showing about 216 volts on the meter. And we can see our magic eye tube is lit. And it does open. So that's looking real good. Okay, so there's no actual calibration at all in this unit. other than changing out resistors. I've made up a short set of test leads here, about 14 inches long. We'll plug this into positive, put this into common, and I'll grab a electrolytic. This just came out of the Johnson. It's 30 microfarad at 450 volts. So we're going to check the capacitance. We're going to do this on setting C4, and I'll connect this up. And like I said, this is 30 microfarad. And look at that, the eye is completely open, right on 30 microfarad. I know that capacitor is, can't believe it's that good. You can see the 30 right here. Yeah, she's opening up right on 30 microfarad. Wanted the power, I had the power factor on mica and paper, so I just put it on 0 when you're checking electrolytics according to the manual. But yeah, it's checking pretty good. So we're going to move this up. This is a 450 volt cap. We'll put 50 volts into it, and you can see it charge up and then open up to 150 volts. Starting to open slower now. It's 250 volts. I don't think she's going to make it. It's 350 volts. Yeah, she's barely opening now. And at 450 volts. I would say this capacitor is very leaky. A good thing again, this control goes back to RC, so you don't have to worry about getting zapped. Now here's a dual cap that came out of one of the Johnsons, so it's got one negative lead and two positive leads, and I left two little clips on it so I can probably be able to get to it. These are dual 10 microfarads at 50 volts. So we're going to bring this here back down to 50 volts, and I'll connect up to one of them, and we'll check the leakage. Oh yeah, I would say that side is leaky. We'll check the other side. It's leaky also. So we want to check our 10 microfarads. That's going to be on C3. And 10 is going to be right around here. Look, it's barely opening. So there's another bad capacitor. Now here's a good cap. 20 microfarads at 450 volts. Up to 50. Yeah, opens up quick, no problems. Have it on the 350. Takes a few seconds for it to charge up, and to 450. No problems at all. And that was 20 microfarad. So we can go back to C3. That's where she's opened the widest, and she's right on 20 microfarads. As you can see right here, dead on. So no calibration required. We'll check a paper cap. This is one out of this machine. 0.2 microfarad, 400 volts. It was 350 volts. Look at that, checks good. So 0.5 at 350, at 400, excuse me. Now we don't have a 400 range on here, so I'm checking these at 350. And it checks good. Now it's not going to hurt it to overvolt it for 50 volts. And you can see it still checks good. Opens right up with no problem. So I got one of these old waxies that come out of something I've worked on. It's a 0.022 at 600 volt. And we can only go to 450 on this meter, but we can go ahead and check it. And let me zoom in just a little bit here so that way you can see the green. And this tube is just as bright and just like a bought one. Look at that, 50 volts. It's already shorted. A couple of big old orange drops. These are 0.22 at 600 volts. We're on the 50 volt range. Opens right up. Go right on the 250. Yep. Cat on up to 450. Oh yeah, they're good. No problems at all. Now that we know that our Knight 670 tester is working fine, I want to look at this power cable coming in. And you see this, it's not fused. And also the off-on switch is tied to ground by this capacitor. Now this capacitor has been removed. So what we're going to do, we're going to add a fuse into that switch side. Then we'll put a couple of safety caps on either side of the power cord. So here on this terminal, just above it, you see I have mounted the fuse block. And this side of the power cable is actually the hot, neutral, and this side is the hot. So what I don't do is switch these two wires around. So the hot will be here, but it will go to the fuse, and then from the fuse back down to the switch. This way that puts the fuse in between the power cable and the switch. And there we go, all finished up. Fuse installed, safety caps in, the switch is on the correct side. The hot side of the line cord is denoted by the stripes on this side of the power cord. So we're going to keep this old school, so whoever gets it, just remember that this side is the hot side. In fact, I'm going to put a little paint on this side. I could change it out to a polarized cord, but if you know, whoever gets this, if that's what they want to do, feel free. Okay guys, the Knight KG-670 RC tester is all done, put back together, case is cleaned up, it's ready to go out to its new owner. And I asked that if you want the tester, leave a comment down below. Please leave one comment if you're wanting it. Don't comment multiple times asking for it. But you know, everybody else that don't want it, just leave a general comment. But if you really want this tester, and you know, and if you have need for it, to just leave that comment below. I don't want someone to you know, want it and win it and then go sell it on eBay. You know, only comment that you want it if you need this type of capacitor tester. I think it'll make a fine addition to anybody's workbench, especially if you're just, you know, getting your lab put together and getting started in it. Anyway, I'm off this week. I'm working on some projects that's been giving me a hard time. You know, it's just not enough hours in the week. You know, 7 to 8 hours out here normally a week, and it's just hard to get to everything and get stuff done. It's not what I had planned to do with this channel. I had planned to come out here and make videos so others can learn, and I want to get back into doing that. But you know, unfortunately, I've taken in a lot of projects, and I've got to back off from that so I can get back to doing what we meant to do with this channel. So with that said, hoping to get some more videos up this week. Got a few more projects that I'm working on. It should be kind of simple and be able to get out of here. So you know, keep your eyes open for that. Anyway, leave your comments down below. I'll run this for a week or so, and like I say, if you really want it, say so in the description box below. Until the next video, we'll see you then. Bye now.